Let's graph some exponential functions using transformations. We know what the general shape of an exponential function is. I have y equals 2 to the x. When x is 0, 2 to the 0 power is 1, so I'm going to have a point at 0, 1. There it is, almost. We're going to go up quickly to the right. I'm going to have another point when x is 1, y is 2, since 2 to the first power is 2, and we'll go on like that. And asymptote, horizontal asymptote, y equals 0 to the left. Let's see if we can make that look like all one graph. It's not too bad. So there's 2 to the x. If I have 2 to the negative x, the negative inside the function next to the x is going to give us a horizontal reflection. The point 0, 1 is going to stay the point 0, 1 because 2 to the 0 power is still 1. I'm reflecting horizontally across the y-axis, so instead of going up to the right, I'm going to go up to the left. Instead of asymptote to the left, I'm going to have horizontal asymptote to the right. And there's my general shape for 2 to the negative x. If I put a negative sign on the outside of the function, that's going to give us a vertical reflection, a top to bottom reflection. Everything up goes down, everything down goes up. My point, we're going to keep track of the point and the asymptote all the way through here. My point, that started out as 0, 1, is going to reflect across the y-axis, so it'll be the same distance away on the other side of the y-axis, which puts us at 0, negative 1. My asymptote starts out at y equals 0, which is the line that we're reflecting over. If I reflect y equals 0 across y equals 0, nothing happens. It's just going to stay there. So instead of going up to the right, asymptote to the left, I'm going to go down to the right. Still going through that point. Now it's at 1, negative 2. Horizontal asymptote to the left, still y equals 0. The only difference is I'm coming up towards the asymptote instead of going down towards the asymptote. So my graph of 2 to the negative 2 to the x is about like that. What else can we do with this? If I have, say, 2 to the x minus 3, this minus 3 on the outside of the function is going to move the entire thing down 3. That means it's going to move the point down 3. It's going to move the asymptote down 3. So my point that's starting out at 0, 1 in my original function is going to move down 3. 1, 2, 3. There's its new home. Where is it? It's now at 0, negative 2. Notice it's not at 0, negative 3. It's not that it moves to negative 3. It moves down 3 from where it started. And it started at 0, 1. So 0, negative 2 is where we end up. Horizontal asymptote started at y equals 0, the x-axis. It's going to move down 3. Down 3 from 0, y equals negative 3. So here's my asymptote. It's like the yellow line on the football field. It's not really there, but it's really nice to be able to see it. So if you dot it in, that serves as a good guide for where the graph should go. The shape hasn't changed. I'm going to go up to the right, asymptote to the left. And there's my graph. And now we have the little bit of everything example. Almost everything that needs to be there. So 2 to the negative x minus 3 plus 1 is what we're graphing here. We got quite a bit of stuff going on here. So let's see what's happening. First thing, I have minus 3 inside the function with the x. It's going to move the whole thing. You might think to the left, but the x is portable. Things are backwards. So the whole thing is going to move 3 to the right. Next, I have the negative with the x, which is going to reflect horizontally left to right. Left to right, right to left, whichever way you'd like to think of it. And finally, We have this plus 1 on the outside, which is going to move the entire thing up 1. And that's in order. We're going to move left or right first. We're going to reflect horizontally next. And move up 1 last. It might be the first thing you notice, but it's the last thing we're going to do. So our point 0, 1 is going to do all of those things. Let's see where it ends up. It started out at 0, 1. We're going to move it 3 to the right. 1, 2, 3. Now it's here. Then we're going to reflect it across the y-axis. So we're going, instead of 3 to the right of the y-axis, my point is now 3 to the left of the y-axis. And then we're going to move up 1. So final answer, final resting place, right there. Looks like we're at the point -3, 2. If you can do that all in your head, that's wonderful. It works for me a little better if I do it kind of like I just did and put it where it belongs and then read off where it landed. Asymptote starts out at y equals 0. If I move a horizontal line to the right, nothing happens, or not that you can tell anyway. It's still the same horizontal line. If I reflect it left to right, if I flip it over the y-axis, same thing. Who can tell? Now the left part of the horizontal line moves to the right part of the horizontal line moves to the left, but it's still the same horizontal line, so no effect so far. If I move the whole thing up 1, now I can tell. So, new location for my horizontal asymptote is y equals 1. That vertical shift is the only thing that has any real effect. Shape, we have the reflection. So instead of up to the right, asymptote to the left, we're going to go up to the left, asymptote to the right, but the overall shape is still the same. And there's the graph of my exponential function.